Welcome back, guys. It's Marlon Echeverry again from the Natural and Social Science Lab at Miami-Dade Kendall campus. Today, we're going to be looking at what is known as balancing reactions. Whenever you're given a chemical reaction in chemistry, one of the first things you have to ask yourself is it a balanced reaction? The concept of balancing reaction is really tied in with what's known as conservation of energy. Conservation of energy is a law in nature that basically says that energy can't be neither created nor destroyed. It can only be transformed. So the idea is when you're given a chemical reaction, like let's use an example of 4 phosphoruses plus 2 hydrogens with a subscript of 2, producing a compound like PH3, the first thing you have to do is you have to analyze this chemical reaction and you have to ask yourself, is it balanced? Well, here I'm demonstrating that I have 4 phosphorus on the left side of the reaction, but on the right side of the reaction, I see that there's an invisible subscript of only 1. So then I realize there's an imbalance in my chemical reaction. So how do I actually go about balancing this? Well, one of the approaches that you can take is you can list the elements underneath the reaction arrow, and then you can proceed and try to balance it. So what I would do is I would ask myself, how many phosphorus do I have on both sides? And then last, I would ask myself, how many hydrogens do I have on both sides? So, for example, here I have 4 phosphorus, so I'll make sure to take note that initially I have 4 phosphorus. On the right side, I only have 1, so I'll go ahead and put a 1 here. How many hydrogens do I have on the left side? I have 2 hydrogens, so I'll make sure to make a note of that. And then on the right side, I actually have 3 hydrogens, so I'll make a note of that. So initially, you just want to take stock of everything you have in your initial reaction. And now is when you go ahead and start adding what are known as coefficients. Coefficients are numbers that go in front of your compound or element. And what you're going to end up doing is you're going to multiply your coefficient times your subscript to try to balance your reaction. So let's go ahead and try to balance ours. We have 4 phosphorus on the left, but we only have 1 on the right. So what number am I going to have to plug in here that when I multiply that times 1 will give me a total of 4? Quite clearly, it would be 4. So now 4 times 1 gives you a total of 4 phosphorus, and you can see that this is balanced. You have 4 on the left, now you have 4 on the right. But one of the most important principles is that as soon as you add a coefficient to a compound, it not only applies to the element of interest, it also applies to the other element. So I'm going to multiply this 4 also times the 3 of the hydrogen. So this is actually 4 times 3 for a total of 12 hydrogens on the right side. And now I can see that I'm imbalanced as far as my hydrogens. I have 2 on the left and I have 12 on the right. So what am I going to do to balance this situation? Well, I come over here to the hydrogen. I see the coefficient blank and then a subscript of 2. So the real question is, what number times 2 will give me a total of 12? Well, quite simply, it would have to be coefficient of 6. So your 6 times the 2 gives you a total of 12 hydrogens. The nice thing about this system is that you can be sure that you're perfectly balanced because you can see that you have 12 on the left and you have 12 on the right. So there's no confusion. The last thing you should do, if they ask you for the sum of the coefficients, if you have to make sure that you put a 1 on an empty blank coefficient space here. So this would be what is known as a balanced reaction here, where you have 4 phosphorus, 6 hydrogen, 6 moles of hydrogen reacting to produce 4 moles of PH3. That would be a balanced reaction.